Okay, so hello everyone. In this video, we will cover switching techniques. So in this video, we will discuss about circuit switching, packet switching, and message switching. And in packet switching, we will discuss about datagram switching and virtual circuit switching. So first of all, what is switching? Switching is the process of transferring data packets from one device to another in a network or from one network to another using a specific device called switches. So in simple terms, we can say we are transferring data using switches. This is switching. Okay, there are three types of switching. First, circuit switching, second, packet switching, and third, message switching. Actually, message switching was used before packet switching, but we will discuss it in the end of the video. Okay, in packet switching, we will discuss about two types of it: datagram switching and virtual circuit switching. Now, moving forward to circuit switching. First of all, circuit switching was originally designed for telephone networks. This technology emerged at a time when there was no concept of OSI layer or TCP models. Okay, today we use computer networks where computers are connected in a network to share data. We have personal computers, laptop, and many other devices. But before computer networks, we had telephone networks. Okay, to connect devices physically in telephone networks, we used circuit switching. Okay, now let me explain this with a diagram. In this diagram, you can see a phone exchange. I guess you probably know about how landline works, right? The same principle applies here. Telephone exchanges are connected to each other. When a user wants to talk to another person, what does he need to do? He picks up the receiver, dials the number, and wait for the tone. Okay, this is what we call connection setup. Now, let's talk about how the connection is established. In GATE and UGC NET, you might encounter theory-based question and numerical problems related to this concept. Let me explain theoretical concept first and then numerical problems. I have noted some key points here that circuit switching works on the physical layer. What does this mean? In layered architecture, data normally flows from the application layer through the network layer and down to the data link layer. But in circuit switching, there is no concept of layer. When you pick up the receiver, establish a connection and start talking, you are directly operating at the physical layer. Okay, in circuit switching there is no concept of layers. Physical connection must be established between devices. Let's see how this connection works. Let's say T1 is connected to a telephone exchange and our landline telephone is connected to this telephone exchange. This telephone exchange in our city is connected with another city's exchange, which is connected to the person we want to talk. Let's say we want to talk to T5. T1 want to talk to T5. What happens when T1 wants to talk to T5? The device here works like a multiplexer, okay, where many people can connect, and there is a wire going out from it. Connection established by connecting the circuit. Okay, from the first exchange, the circuit connects to the next exchange. Okay, where one port connects with it. Okay, and then to the final destination. Now we have completed a dedicated path or communication. Here in the diagram, we can see there are switches and all the devices connected with switches. Let's say T1 wants to talk to T5, which is in another city. Okay, so we have to establish a connection between them. Remember this key point here, this important key point here: circuit switching uses a dedicated path. This means even though these people aren't connected point to point directly, it appears if they have a dedicated connection. Okay, once the connection is established, you can talk as long as you want until you disconnect the call. The second important point is contiguous flow. Once the connection is established, you start talking and there is contiguous data flow, unlike layered communication where data is divided into segments, packets, and frames. Here you talk directly and all data flows contiguously. This is important point: contiguous data flow. Now this leads to one more important point. If T1 is sending data to T5, can that data arrive out of order? There is two order: sequential order and out of order. Can this data arrive out of order? No. Let's assume we are sending message hello, how are you, and question mark. Okay, is it possible for T5 to receive them in different order, like how, you, hello, then are, then question mark? No, it cannot be out of order. It will always maintain the sequential order, because if we are talking on the phone saying hello, how are you will not arrive before hello. The data always flow in the order. Okay, the third important point is about headers. What is header? Now, for better understanding, you can see here on the screen that address on the envelope, we can call it a header. It contains sender's address and receiver address, and in computer networks, headers contain source address and MAC address and many more things. The address containing envelope is header. Okay, why do we use header in networking? Header contain information like source address and destination address. In the network layer, we have source IP and destination IP. In transport layer, we have source port and destination port. In data link layer, we have source MAC and destination MAC addresses. But in circuit switching, you don't need any headers because we are working on physical layer. Okay, this is circuit switching. This is the advantage of this setup process, because although setup is time consuming. Once it's done, you don't need to include any headers with your data. Okay, the data will flow properly because during setup you have made reservation, you have reserved this port for your use until you terminate the connection, you have reserved the bandwidth of this link or channel, you have reserved buffer space and resources of this connection. Okay, so no one else can use these resources while you are using them. Okay, so there's no need of headers, packets will keep flowing in one line without requiring address information. This is circuit switching. Now let's talk about efficiency. The efficiency of circuit switching is relatively low. Why? Because of the reservation system. When resources are reserved, other can't share them. Imagine you are talking to someone on the phone and say, wait for 2 minutes, I will finish my TV show and then I will talk to you. And you just put the receiver aside. Okay, you haven't cut the call. Okay, and you just set the receiver aside. The connection is still active. The reservation system is still in the place. The bandwidth is still reserved. But you are sending data or talking or not? No, you are unnecessarily keeping resources reserved. Okay, which reduce efficiency. Moving to the delay, circuit switching has less delay. What kind of delay I am talking about? The delay caused by nodes along with the path. Okay, in circuit switching there's no delay from intermediate nodes because data flow directly from one port to another without being stopped. Okay, unlike packet switching or message switching where devices like routers store packet, process them and then forwards them, circuit switching has no store and forward mechanism. As soon as you start talking, no one stores and forward your data. Now there is a problem with circuit switching. Since it works at the physical layer, we can't divide data for transmission. Okay, and what we need most importantly is efficiency. That's why circuit switching is best for telephone network but not suitable for services like email or WhatsApp or computer networks in general. Okay, now the last point to consider is the total time. In numerical problems you might need to calculate the total time taken. First there is setup time, which I have already mentioned. It is the time needed to make reservation. Okay, you can't calculate this theoretically, it will be given in the problem or question. Okay, then there is transmission time, which is the time taken to transmit your message once the setup is complete. Okay, transmission time equals to message size divided by bandwidth. Next there is propagation delay, the time it takes for a signal to travel from one point to another, which is distance divided by velocity. This is propagation delay. Finally there is tear down time, which is the time taken to free all the resources. When you terminate the connection, the total time is the sum of all these components. Okay, these are the major concept of important points related to circuit switching. The total time equal to setup time plus transmission time plus propagation delay plus tear down time. Okay, now moving forward to the packet switching. The concept of packet switching is completely different from circuit switching. In packet switching, data is transmitted in the form of packets. Here we use the concept of layers such as OSI layer or TCP/IP layers, where data moves from application layer through the transport layer, then the network layer, then finally exits through the physical layer. Okay, let me explain key points about the packet switching. First, data is divided into packets. In packet switching, data isn't transmitted continuously like in circuit switching. Okay, instead the network layer and data link layer break the data into small packets. Okay, for example, if A wants to send data to B, the data is divided into packets like P1, P2, P3. These packets are then transmitted individually over the network. Second, packet switching works at the data link layer and network layers. Okay, there are two types of packet switching: datagram switching, which is more common and included in our syllabus, and virtual circuit switching. Datagram service operates at the network layer while virtual circuit operate at the data link layer. The next point is packet switching uses store and forward mechanism. Unlike circuit switching where a dedicated path is established first, packet switching implies store and forward. When A sends packets to B, then the switch S1 store the packet in its buffer, process it by checking routing table and then forward it. This introduces some delay but improves efficiency because the network resources aren't reserved for a single connection. Okay, now next point is packet switching has higher efficiency but more delay compared to circuit switching. In circuit switching, if a connection is reserved but not used, like when a phone line stays idle, okay, so resources are wasted. But packet switching avoids this by dynamically routing packets. To improve efficiency, packet switching uses pipelining. For example, if A sends packet P1 to S1 while S1 is forwarding it to S3, A can simultaneously send packet P2. Okay, this parallel transmission reduced by the total delay, and this we will call pipelining. We can send data simultaneously. Now, in packet switching, the total transmission time equals the transmission time multiplied by number of switches plus propagation delay. Each switch is in the packet switching independently process packets. Transmission time increases with more switches. Okay, Now, for what is the formula of this? Transmission time into number of switches plus propagation delay. This is what the formula of total time of packet switching. Now, moving forward to the types of packet switching. Two types of packet switching are there: datagram switching and virtual circuit switching. In datagram switching, there is no reservation of resources like switches or bandwidth, as same as packet switching. Okay, as we can see it in diagram also, that packets P1, P2 and P3 are being sent by available paths and switches. But in virtual circuit switching, it is combination of circuit switching and packet switching. In the first, we send a packet, and by which route this packet goes, we reserve that route and resources. Then we will transmit other packets through that route. Okay, no other user can transmit that resource until we are done. Okay, in this diagram, we reserve S1, S5 and S4 resources. This is virtual circuit switching. Circuit switching was for telephone network, and this is for packets. It is an advantage. Now we will discuss about its important points. Let's start with datagram switching. The most important characteristic of datagram switching is that it's connectionless. This means there are no reservation. If A needs to send to data to B, then the data is first divided into packets, then we send those packets directly towards B without reserving any resources. We don't reserve CPU, buffer or bandwidth. Everything is provided on demand. On demand means that as soon as packet 1 arrives at the switch, it goes into the buffer. This is store and forward mechanism I explained earlier. The packet is stored and processed. To store it, we need a buffer or space. Okay, to process it, we need a CPU. To transmit it, we need a bandwidth. Okay, all these resources are allocated on demand. If resources are already in use, then packet P1 has to wait. Okay, this is a key aspect of connectionless service, and this is datagram switching, as same as packet switching. Virtual circuit is connection oriented. This means that before sending data packets, there is a reservation process. One global packets, we can say we are sending P1, is sent all the way to B. Okay, as this global packets travels to B, it reserve all the switches along its path. Okay, it reserve buffer space, CPU and memory. So reservation is used in virtual circuit switching, making it hybrid approach. Okay, virtual circuit is 50% packet switching because data is divided into packets, and then 50% circuit switching. Okay, because it involves reservation. The next point is related to path and packet order. Okay, in datagram switching, packets can follow different path. For example, P1 might take another path and P2 another, and so on. Okay, this means that when packet reach B, they might not arrive in sequential order. Okay, they might be out of order because they are following different path based on routing tables. Okay, this improve traffic management as we utilize our all possible paths. Okay, packet might arrive out of order. In virtual circuit, packets follow the same order because the global packet has already reserved a specific path. All data packets follow the same path, ensuring they arrive in the sequence P1 first, then P2, then P3. Next, let's talk about overhead. In datagram switching, the overhead is high. What does overhead mean here? Let's say I need to send 100 byte of data. Can I send just those 100 byte directly? No, I need to include headers. Headers contain information like source address, destination address, TTL field. Think of a header like an envelope, as we discussed before. If you want to send an item via courier, you put it in an envelope. An envelope is extra weight, and that's what we call a header. In datagram switching, headers are more abundant because all packets follow different paths. Each packet needs its own header with routing information. This increases the overhead. Okay, in virtual circuit, there is less overhead. The first packet, known as the global header, contains all the routing information. The rest of the packets contain local headers. Okay, but they don't create as much overhead as in datagram switching. Okay, regarding packet loss, it is higher in datagram switching than in virtual circuit. Why? Because in datagram switching, all packets follow different paths. Packet P1 doesn't know like which way packet P2 is going, and so on. This increase the chances of packet loss along the way. Okay, in virtual circuit, packet loss is less because every packet follows the same path. It is like knowing the route in advance, which makes it easier to track packets and reduces the chance of loss. Let's also discuss about cost. In virtual circuit, we need to establish a connection every time we want to send data. This means making reservation for CPU, bandwidth and buffers, which affects efficiency. In datagram switching, there is no reservation. Resources are allocated on demand. If a source pauses sending data, those resources can be given to someone else. This makes datagram switching more efficient and less costly. Okay, now let's talk about delay. Delay in virtual circuit are less than in datagram switching. Why? Because in datagram switching, a packet might arrive at a switch and have to wait if resources are not available. It's like going to a restaurant without a reservation and having to wait for a table. In virtual machine, Since resources are already reserved, there's no waiting time. You can go to a restaurant directly to your table and start ordering. Okay, datagram service is widely used nowadays, especially in the internet, which we call the IP network. The entire network layer that we study relies on datagram services. Virtual circuit is used in technologies like frame relays, X.25, and ATM. ATM is what? Asynchronous transfer mode, not automated teller machine. These are the key difference between datagram switching and virtual circuit switching. Now let's discuss message switching. Moving forward to message switching. Although the concept of message switching came after circuit switching, it predates packet switching. Okay, the chronological order of these switching concept is circuit switching, message switching, and then packet switching. In circuit switching, communication begins by establishing a connection. Okay, once the connection is fully established, data transfer starts. Circuit switching was designed for telephone networks where devices are already connected with each other. Message switching was introduced around 1960s with the concept of store and forward mechanism. Rather than sending data continuously, message switching sends message one by one, which is called hop to hop delivery. What is hop here? Hop means we can say a device, okay, like router or switches. For example, if A wants to send data to D, in circuit switching, a connection would first be established between A and D. After that, data can be transferred continuously. But in message switching, no direct connection is created between A and D. Okay, A simply transmits its message, which reaches the next hop, like a switch or router. The switch store the message, process it to determine the route, then forward it to next hop. Okay, this process continues until the message reaches its destination. Initially, messages were stored on hard disk, which caused significant delays. Later, RAM was used for storage because it's much faster than hard disk. This hop by hop delivery approaches differs completely from circuit switching. This is what message switching. In message switching addressed the disadvantage of reservation in circuit switching, where bandwidth, CPU, and resources were kept reserved. Okay, message switching is actually a predecessor of packet switching. In packet switching, instead of sending one large message hop by hop, we divide the message into small packets. Okay, this achieves parallelism or pipelining, where multiple packets can flow in parallel, reducing delay and increasing efficiency. The basic principle of message switching is its store and forward mechanism strategy with hop by hop delivery. Okay, the advantage is that there is no reservation, making it more efficient than circuit switching. The delay is higher because every hop processes the message, and if we compare message switching with packet switching, the main difference is that the packet switching we send multiple small packets in parallel over different routes rather than one big message. In summary, understanding these switching techniques, circuit switching, message switching, packet switching, like including datagram switching and virtual circuit switching also, these switching are very important for our GATE exam, UGC NET exam, or even for our university exam. These are very important topics. So that's it for this video. We will meet in next video. Until then, bye bye.